everyone, and this is my CVE video for the final project. This 2021-4034, a local privilege escalation in the PolKit's PK-exec program, which is a set UID root program installed by default on Linux. Okay, so this is the original advisory by the original authors of this CV, so I'm going to use this to walk through the vulnerability and the exploit. Okay, so pkexec, we can use pkexec to execute commands with elevated privileges. Okay, so like for example, say we can use pkexec. First, let me search another user that is allowed to use pkexec. It will say call pkexec followed by the command I want to execute. It should give me a root ID, right? Because I'm executing this command as a root user, so ID should give me this output. Now, if I was an unprivileged user that is not allowed to use pkexec, and if I call this, it's gonna ask me for a password of a super user. Now, if I was an unprivileged user, I shouldn't know this password, right? If I tried entering my password, it's not gonna work. Okay, so I can still call it, but when I try to execute this, whatever the commands follows pkexec, it's not gonna work. It's gonna ask for super user password. Okay, so it's vulnerable since its creation in 2009 up until 2022, I believe. Yes, it is the published date. Okay. And any user can exploit this vulnerability. Let's get started. Okay, so where does this vulnerability lies? In the source code for the pkexec program, which you can find on Linux, on this line, in this section of the code right here, if the number of command line arguments to the pkexec program is 0, that is, the argument list is empty, then argv of 0 is null, right? Because argv is null terminated, so argv of 0 is null. But on this line, we're calling string duplicate on argv of 1 because n is permanently set to 1 on this line. So path, we duplicate argv of 1 and assign it to path, and then we pass that outbound read into this function find programming path, and then whatever the return value of this function is, we assign it to s, which is then assigned to argv of 1. Yeah. Yeah, also. Then, what does this function do? Find programming path. It searches for an executable name value in the directories of our path environment variable. Okay, so whatever the value of the path environment variable is set to, let's say is set to this value, like literally this is the value of this name of the directory. And if this directory exists and contain an executable name value, which is the first environment variable, which is the outbound read that we end up passing as the argument to this function. If an executable name value exists in this directory, then the pointer to the name, the pointer to the path to that executable is written out of bounds to argv of 1, which is the first environment variable. Okay, this outbound read allows us to introduce another environment variable into the program in this form, right? So we can introduce an environment name variable name that has the this value. Okay. Now, how can we exploit this? Because on this line 302, it's gonna remove all of our environment variables, as is what it says in the original source code. Nuke the environment. So we gotta do something before this line. We gotta exploit it somehow. Now, this loop here goes through. It goes starts from 0, goes through all of these values, all these environment variables, and it gets the corresponding value for each key, and calls this validate environment variable function. And let me just pull up to that function. That function is this function right here. And if we ends up, if this comparison, if we go inside this if loop, if we have a shell variable that is not found in this file, that is, so let's say now exploit, we introduce a shell variable, the value, we introduce a value for the shell variable that is not found in this file, then it's gonna trigger this uh, block code right here. Right? It's gonna call log message, which in turn calls gprint error. Right now, this is the most interesting part of the exploit, because this is where we actually exploit this bug. Right. So gprint error normally prints UTF-8 error messages, but it can print messages in another char set if the environment variable char set is not UTF-8. Again, we can craft an environment variable, we can introduce a different value for char set, and then to convert messages from UTF-8 to another char set, it calls this function, and this function executes some small shared libraries. Now this is the dangerous part, right? Because no, so to convert messages from one char set to another, like the configurations are read from this file right here, right? This path right here. Now on 64-bit systems, the path is gonna be different. It's gonna be something like, okay, it's gonna be something like this, right? And this is what the configuration file looks like. You have a module, and then the from char set, like from which char set to what char set, and then what program is gonna call, or what library is gonna load to perform the conversion, right? Now we don't have control over this file, this default file, right? Because let's say, well, we don't have permission to write to that file, but so then we can make it load our malicious library, but we can make it read from another configuration file by setting the environment variable gconv path right here. If gconv path is set, it's gonna read from whatever the value gconv path is. So in conclusion, this vulnerability allows us to introduce gconv path into the pkexec environment variable, which then will cause gprint error to load a share library, right? So we know that we want to introduce gconv path, right? So how can we do that using this right here? So what we can do is that we can create a directory named gconvpath equals to dot. Right, we can do gconvpath is equal to dot. Is the name of our directory right here. Now in this directory, if it contains an executable name, let's say PwnKit, and then we can do touch gconvpath PwnKit, right? And we're gonna, because it has to be an executable, we're gonna have to set the executable bit for that file. So okay, if this and that this exists, then the outbound write is gonna write gconvpath equals to dot the name of the directory slash the executable. This is gonna be the old outbound write to that's gonna be performed in this exploit. Right. Now we have set the gconvpath, which is the current directory slash PwnKit, right? So we gotta make sure that we have a directory named PwnKit, and that in this directory we have a gconv models file. Right? So we can gconv models. Note that is a dash, not a back, and not underscore. And then I'm just gonna copy one of this. Say our configuration file has something like tfa// and then I want to convert it to PwnKit // and then our share library is gonna be called that. Okay. So all that's left to do is to create a small share library. That's gonna give us root, right? And that is quite easy to do. We can just have let me just have one of demo. Just gonna copy from the demo PwnKit.so. Let's say we have compiled this share library, and then we're gonna copy it and bring it to test, and then PwnKit. So this is what we have in our PwnKit directory, right? So this directory is what we have, and then all that's left to do is that, because we know that it's going to execute this share library, which is going to give us a shell, right? What we can do then is we can call pkexec, and then we're gonna set the argument array to null, to empty, and then in our environment, for our environment variables, it's gonna be null terminated, and then the first value is gonna be PwnKit, right? Because this is the executable is that it's gonna look for in this path, which is gconvpath equal dot. So it's gonna look for PwnKit in this directory. Sorry, that's right. And then, remember, we also have to set our shell variables to be something other than. So we can call it PwnKit. Pretty sure there's not gonna be in that file. And then our char set is what we set it to in the gconv models from UTF-8 to this PwnKit. So we call PwnKit, right, so which is the name of the char set that we're going to convert it to. Okay, that, and then we're going to compile this. This exploit assumes that we have GCC installed on the target system. So if we execute this exploit and a run ID, it should be root, right? And that's it. I know that I skipped a lot of details, but in this exploit, because there are just lots of them, and this video is supposed to be under 10 minutes, which I don't think it is. But yeah, these are like the important points in this exploit, and yeah, that's it.